Okay, welcome everyone. This is the week 2 webinar. So it's our second regular, webinar on statistics in this class. And let me tell you what the plan is for today. I'll start out with any questions that you might have. I'll be watching the chat box in case you have questions. I'll be always happy to answer them. And then we're going to move into chapter 3. And that is really all about probability. So I'll start out by defining probability. And we'll do some examples and chat about probability. And then just a note, I don't know if you ever bought one of these guys, but it's lottery. And next week we'll actually talk about why I bought one once, more than once. And then, maybe next time I'll buy one again sometime. But for now, we'll talk about how likely is it that I'll win the lottery when I buy a ticket. And we'll see how to compute those kind of things. Then this looks really easy. And sounds easy, doesn't it? So it turns out that we use the word and for a specific thing in probability. And it's very important. So we also use the word or. So we might want to say, what is the probability of this happening and this other thing happening? Which is different than saying, what is the probability of this happening or this other thing happening? And we'll talk about that. There'll be some formulas, some math formulas for that. Then we'll talk about the word given. What is the probability that this happens given this other thing happens? And we'll talk about how to find those probabilities out. Very important, very important. We'll look at what we call mutually exclusive events. We'll also look at what does it mean for events to be independent and dependent. And then finally, I'm going to spend some time talking about Project One. So hopefully at this point, you have found partners. As I mentioned last week at the webinar, that was something you were supposed to do last week, and hopefully you have. If not, you need to go find partners, post on the Project One discussion board and say, please get, I need partners, or someone who did post back saying, I want to be your partner, because it is important that you have partners for the project. 3 is best. 2 is allowed, but 3 is better. And so that's the deal. And I want to apologize for last week. I don't know if you remember at the very end, the internet was dying. It turns out our college's internet went down. Believe it or not, that is the first time that ever happened in my, I think, 15 years of doing webinars at the college, where the internet went down while I was giving a webinar for this class. So it was weird. So I apologize for that. For those of you who did not watch it live, I posted last quarter's webinar on YouTube, which basically, covers the same material. And I made sure that the secret word worked from last quarter. Last quarter won't work for this one, unless maybe I shouldn't say it, but unless the internet dies again or something happens to to the process, because hopefully that won't. Hopefully no more tech issues. Tech issues don't usually happen, just happened. So stuff happens. I have no way of, making it so that the internet doesn't die. I mean, things can happen. So I apologize. So I want to ask you, are there any questions about anything? And you can post in the chat box. I also want to mention I'm grading. I graded your initial discussion post assignment on the 2 truths, 1 untruth. I'm about halfway done grading the week 1 assignment on sampling techniques. And as you're going to learn about me, is I'm not a procrastinator. I have a lot of students, so it does take me time, but I'm not one that's going to take weeks to grade or anything like that. I usually grade within a day or within 2 days. Usually it could often take a couple days to grade, but should be finished grading by the end of tomorrow, hopefully, unless some disaster happens, but hopefully it doesn't. So that's my plan. And for some of you, I'm finished all of the grading for the week. So you can look in Canvas and see my comments and understand how the grading works. So I'm looking at the chat box. I'm not seeing any questions. But I want to say one more thing about the grading or about what I looked at. It's very important that when you go to the discussion post, read the instructions. It tells you what I ask you to put in, and some of you didn't. For example, in the 2 truths, 1 untruth, I wrote that you were supposed to post how you're going to be using statistics in your future. And a lot of you didn't. And all I ask is, and it's not a hard thing to do, you just write that down. All you do is say something and I would have accepted it. But if you didn't, then you lost a point or two. So that's just a note. So it is important that you kind of follow the instructions on the discussion post. Tomorrow may not work. I'm not sure yet. If you want to meet with me tomorrow, drop me an email in the later afternoon, like 4 o'clock. There's a chance I'm going to be doing something intense tomorrow. Those of you in Tahoe will understand, and that is do a bike ride just for fun around Lake Tahoe. And if you know anything about that, it's about 75 miles. It'll take me like 7 or 8 hours to do. There's a chance I might not. We'll see how I feel in the morning. And then if I do that, then I'll be back in the late afternoon, like 4:30 or something like that, or 4 o'clock. We'll see. So I'm not sure. But definitely, because tomorrow's the day I don't have office hours. I do have office hours on Wednesday, Thursday, Friday. I had them today. Always happy to do that. Tomorrow's a maybe. Okay. Other questions? Okay, if there's no questions, let's talk about probability. So you've all seen one of these guys before. It's called a quarter. And I can take that quarter and throw it up in the air and flip the coin and look to see what I got. The question is it heads or is it tails? And the question I have for you, I like to start out with a really easy example. What is the probability that if I flip this coin without cheating, that it'll land heads? See if you can tell me in the chat box. This is supposed to be easy. Okay, so one thing, y'all have the right idea, but let's not write it as a percent. Let's write it as a number, a probability number, which is different. Yeah, 0.5. I'm going to write it as a fraction. And there's a reason, even if you don't like fractions, we're going to do a lot of them today. So sorry about that, but it's part of the class. So we're going to write as a fraction. And there's a reason why I want to write as a fraction. And it is 1 over 2. Good, good. Okay. And the reason why it's 1 over 2 is that there are 2 sides of a coin. Hopefully everyone knows that. So the denominator is how many different ways something could happen. In this case, there's 2 ways. You could have a heads, you could have a tails. The numerator are how many ways there are to make what you're looking at happen. In this case, heads. And I know this is like way too easy, but there's 1 head on this coin. So that's why the probability of heads is 1 divided by 2. Any questions on that idea? Any questions? Okay, so that's important. So the numerator is how many ways what you're looking at can happen. And the denominator is how many total ways anything can happen. And that's how probability works. Let's do one more example that at least, I don't know if younger people know cards that well, but we'll do them anyway. One thing is I'm in Tahoe, and Tahoe's a big gambling place. And these are cards. And if I mix my cards up and pick a card. What is the probability that this card is a spade? And right now, all you see is the back of the card, which sadly says Lakeside Inn was closed during COVID. But what is the probability that this card is a spade? And again, you want to think of it as fractions. So I'll even start out by going into fraction mode. Okay, so I see one answer. See if anyone else has answers. Okay, so one thing you want to look at is how many cards are there in the deck? Oh, if you don't know, then that's okay. I don't assume you all know how many cards are in a deck, but there are 52. Then the question is, how many spades are there in the deck? So here's an example of a spade, 5 of spades. Here is another example of spade, 10 of spades.
No,
So not 1 out of 52. It's how many out of 52?
Sí.
So how many out of 52 should it be? How many spades are there in a deck?
Sí, no quiero mucho.
Okay,
Right.
I will.
How many spades are there in a deck? So it turns out there are 13. If you don't know cards well, I'm just going to tell you. There's ace 2, there's ace 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, which is 13 different spades. So the probability of getting a spade out of this card deck is 13 out of 52. Okay. So you may or may not know, but Tahoe, again, you walk into any casino, you're going to see them playing cards. And you can play poker, you can play blackjack. I'm not going to get into the details of that stuff. But all of that, to be really good at it, you really have to understand probability. Okay. You think I was good at it? Any thoughts? See, it turned out I was really good at it. And then they told me they were going to kill me if I ever came back again. So I never came back and played again because I was a card counter. Nowadays, it's different. It's not mafia driven, but it was mafia driven in those days. I made a lot of money. So I was used probability and statistics for hours and just made money. It's not cheating. It's using math, using probability. So we're going to be using probability. We're going to be looking at probability and doing all kinds of things. And I do lots of stuff with probability, sometimes to make money. Okay. And I wasn't stupid. I never went back to the casino because I didn't want to die. Okay, so the definition of probability again is probability of A is a number in A divided by the number in the entire set. All right, so now let's do something a little harder. Let's suppose I pick, instead of a card, I pick one card, and then I'm going to drop it, and then pick another card. So we have a first card and we have a second card. What is the probability the first card is a king? That's supposed to be really easy. What's the probability the first card is a king? Okay, let's think about how many cards are there. There's 52 cards, so the denominator is 52. How many kings are there? Yeah, there's 4 kings. So it's 4 out of 52. Will be the probability the first card is a king. One thing I'm not going to require you to do is do any kind of like fancy reduction of fractions. You're welcome to, but I like writing as 4 over 52 because it tells a story a little better than to like reduce it and write as 1 over 13. the 4/52 is better for storytelling and understanding what's going on. Okay, now I want to look at what is the probability that, remember, I picked not just one card, I picked 2 cards. And what is the probability that both cards are king? Okay, now it's a little more difficult. So we have to do a few things first. One thing we have to do is we know the probability the first card is a king is 4 out of 52. On the other hand, if that first card really was a king, there it is, see the king? And I take that king and I drop it down. So if I'm told the first card is a king, what's the probability the second card is a king? That changes things. So now what we're going to do is we want to write down this one right here, probability of K2. And then we use a little vertical line segment, and that means given K1. So first card is a second card is a king, given that the first card is a king. And to do that, we're going to do the fraction again. And now the idea is that was our first card and it's gone. How many kings are left? How many kings are left in my hand here? There's 3. So the numerator will now be a 3. How many cards are left? $51. So 51. So the probability that the second card is a king, given the first card is a king, is 3 over 51. Any questions on how I came up with that answer? Okay, so we're going to use what's called the multiplication principle. And that says the probability of A and B is equal to the probability of A times the probability of B given A. So they call it the multiplication principle because if you look at the right-hand side, there's a multiplication there. Okay, so today, actually, we got some formulas. It's going to happen. So if we want the probability that both are kings, we find the probability the first is a king times the probability the second is a king, given that the first is a king. Any questions on that? And the good news is we've already done both of those, right? The probability the first is a king was 4 out of 52. And then we're going to multiply that by the probability that the second is a king given the first is a king, which is 3 over 51. Any questions at all on that idea? Okay. And by the way, we can work that out. I think I'm going to show you how to do it, making it a decimal. And if I just go to, what I like is Google just does it for you. If you just go 4 divided by 52. If you didn't know the times for computers, typically is a star, that's shift 8. That's how you type it into a computer. So 4 divided by 52 times 3 divided by 51. And you'll notice Google says 0.00452, etc. When you're doing the assignments or the exams, make sure you read the instructions. If it tells you to carry it to 4 decimal places, do at least 4 decimal places. If it says carry to 5 decimal places, do 5 decimal places. So make sure you read the instructions in the questions on the homework that you're doing, on the assignment problems. Any questions so far? All right, now we're going to do it harder. Okay. Any of you play poker? I used to play poker with friends, but I needed to quit because I was going to lose all my friends because I did math. I can't not do math while I do poker, and then I just win. But anyhow, so if you pick 5 cards for a poker hand, what's probably getting a royal flush? And the probability of royal flush is the number of royal flushes divided by the number of poker hands. So if you don't know what a royal flush is, what it is, it means you have ace, king, queen, jack, 10 of the same suit. In any order, order doesn't matter. So it turns out, how many ways are there of getting a royal flush? This is really easy. Let me give you one example. Ace, king, queen, jack, 10 of spades. That's one way. How many different ways are there of getting a royal flush? Not that many, by the way. 5, no. 4, good. Because you can get them in spades, in diamonds, in clubs, or hearts. So that's going to be 4. Now comes the hard part. If I grab 5 cards from the deck out of a 52-card deck, how many different 5-card decks are there? 5-card hands are there out of a 52-card deck? I don't expect any of you to come up with that, but what I do expect you to do is listen. And what we're going to do is we're going to go to the calculator. And the calculator we're going to use for this is called combinations and permutations, number 5. And then we wait a while for it to load. Okay, so N is going to be the total number that could of things that you're picking from, and that's 52. R is going to be how many you're picking, and that is 5. Okay. Any guess on how many ways there might be of picking 5 cards out of a 52-card deck? Okay, here's the idea. You're not going to guess it. You can't list them all. Okay, I don't know if you'd live that long. So let's see, we're going to calculate, we're going to do CNR for this combinations, for this, how many ways there are picking when order doesn't matter. If order does matter, it's PNR. But if order doesn't matter, it's CNR. And it's around 2.6 million ways. There are a lot of different poker hands. There's just no way you could list them all. But you can trust me, since I coded this, that I did the math right and made it work for the computer. You don't have to understand all the details. What you have to do is know how to use it to get there. And there's my number of ways. I'm going to copy it and paste it into here. And there we go. Probability is very, very small. Any questions on that? Okay, and that happens sometimes. All right, let's look at another example. Okay, let's suppose that you have a test. Test has 20 questions. And each question is a multiple choice question, at which there are 4 choices. And let's suppose that you have no clue about any of the answers. Okay, but it's better to guess than not to. You might get some of them right. What's the probability of getting all of them right? What's the probability of getting all of them right? Okay, and the difference between this and what we just did the last few is this is going to be a probability of these 20 things occurring with replacement. Because if you guessed A for the first one, you're allowed to guess A for the second one also. Maybe you'll guess B for the third one and C for the fourth, and maybe B again for the fifth. So this is called with replacement because you can repeat a prior answer. Any questions on that idea? When you have a probability with replacement, then we're going to find out the probability of the first one happening, which is 1/4. There's 4 choices. One of them's right. You got a 1 out of 4 chance of getting it right. The second one, well, you also have a 1/4 chance of getting it right. No matter what happened in the first one, if you're just guessing. The third one, you have another 1/4 chance of getting it right. Etc., etc. And there's 20 of them. So you're going to multiply a fourth times a fourth times a fourth times a fourth 20 times. And you remember how to write that or what that is in terms of math? Any thoughts? See, close. It's not quite 4 to the 20th. You're close to, you get the right idea, but that's not quite what it is. It's 1/4. To the 20th power. Any questions on that? Okay, very small chance, by the way. 1/4 to the 20th is, I don't know if you know, but 1/2 to the 10th is a kilobyte. You might have heard of that word before. It's around 1,000. 1/4 to the 20th is 1,000, thousands, it turns out, which is about 1 trillion. So there's like almost no chance of getting them out. All right. Any questions on this example? Okay, so as I mentioned, this one is with replacement. And that means the probability of A and B, when you have with replacement, is the probability of A times the probability of B. And that's what we just did 20 times. Okay, so now, buy a ticket, lottery ticket. Okay, and any of you have ever bought a ticket before? Okay, so if you have, I bought this ticket a little more than a week ago. I don't know if you remember what was going on a little more than a week ago. It was worth over $1 billion. By the way, do you think I won? Oh no, I didn't win. But next week we're going to learn that my expected value is positive. And well, that doesn't mean anything to you today, but next week we'll talk about it. Okay. So we got a Powerball. And by the way, I bought Powerballs. I think I have one in here too. Got the Mega Millions that I bought. I buy whatever has a positive expected value, which is not quite true now. So I will let you know this is an old ticket. Okay, so kind of next time I play, what's the probability of winning? So here's how we do it. First thing is you have to understand how the lottery works. And for the Powerball, you pick 5 numbers between 1 and 69, and 1 power number between 1 and 26. And to let you know that the 5 numbers between 1 and 69 are without replacement, the 1 number between 1 and 26 is with replacement. And that is actually really important. So how many ways are there of picking 5 numbers between 1 and 69? Well, if we go back to the calculator and we go 69 and 5, and hit calculate, there we go. Over 11 million ways. So that means we're going to have around 1 in 11 million chances of getting those first 5 correct. Any questions on that? Okay, but then I need to multiply it by the probability of getting the power number right. Okay, which is 1 out of 26. And there we have it. So I want to let you know that when we work this out, I got 0.0000000342. Okay. By the way, what do you think? Pretty good chance if I play the next time? What do you think? Should I put a down payment on a big, should I, put an offer on a big house? No, this is like nothing. I want to give you a heads up though that happens on calculators, including mine, most calculators, on computer calculators. Often it won't show this way. Often it's going to show, it'll show 3.42 E negative, let me look at it, 9. So you'll sometimes see it written this way. And it's very important that you understand what that means. Anyone know what the E negative 9 means? Anyone know? Exponentiating, you got the right idea. Yeah, it's called scientific notation. It means move the decimal over to the left 9 places. And the first place is free, you put it next to the 3. But then for all the rest of them, you're going to get zeros every time you move it. So the first is free, and notice now next to the decimal, there's 8 zeros. If you're ever asked for a probability and you write something like just 3.42 because you didn't read this part, this E negative 9, you can never, ever, ever have a probability of 3.42 because probabilities can never be bigger than 1. So make sure that you move your eyeball to the right and see that E. And if you're using a smartphone, by the way, often that E won't show up and you're going to have to scroll until you get to it. So that's just a big note about smartphones or a small computer. It's a computer with it's not too big an area to to put in the number. Sometimes you're going to have to scroll until you find it. So I want to say that's a very common mistake. So don't make that mistake. Got it? Any questions at all on this example? Can the negative ever be a positive? It can't for probability, because if it was positive, you can have a number bigger than 1. Can it ever be for numbers? Yeah. But probabilities have to be numbers smaller than 1, so you can never get a E positive. That makes sense? Good question, though. Okay, so let's do another example. And I want to let you know, this is an example. I should give you a warning about this. We're only covering 1 chapter this week. Does that mean we have an easy week? What do you think? Yeah, the answer is no. There's a reason why we're only covering 1 chapter. It's a hard chapter. So I want to give you a big warning that a lot of people, especially those that don't like math much, they consider this the hardest chapter of the entire book. So be ready for a tough chapter, but it's only 1 chapter. And I like to say that probability is a lot like kickboxing. Any of you ever kickboxed? Okay, so I let you know, I've taught a few things in my life. Math obviously is one of them, math and statistics. The other one I've taught was karate. And I'll tell you, watching somebody kickboxing is a lot easier than being in the ring kickboxing. You never get hurt when you're watching somebody else. It's like comfortable and relaxing. Then you jump in the ring and you got to kickbox, and it is brutal. And probability is a lot like that. Watching me do it is not the same as doing it yourself. So be ready when you're working out problems that working out your own problems are much harder than watching me do it. Does that make sense? So a big, heads up on this chapter is these get tough. So here's an example. It's a word problem example. So suppose that 20% of all students taking stats at Lake Tahoe Community College are African Americans, and 40% of all students at Lake Tahoe Community College, of all stat students at Lake Tahoe Community College are non-STEM majors. If 22% of Lake Tahoe Community College stat students, non-STEM majors, are African American, and you pick a randomly selected African American taking stats, find the probability that student is non-STEM. Okay, so I want to let you know what makes this hard is it's a very long word problem. And you have to be able to take a long paragraph like this and figure out how to turn it into probability statements. And that can get really tough. So here's my suggestion on getting these right. Step one I suggest is to read it. Hopefully you all know how to read. That's not the hard step, by the way. You can read it quickly, it's fine. Step two is to read it again, but not quickly. Read it again and read it every little phrase at a time. Anytime you see a number, turn that little phrase that has that number into it as a probability statement in symbols. Okay? And if there's a question about probability, turn that into symbols also. So let's go ahead. Okay, and I want to give you a heads up on something, just so you don't get like mad when you find out this isn't right. If I use the word suppose, do you know what that means? That means I just totally made up these numbers. So, don't like quote me that we have exactly, 40% or 20% of all students are African American. I have no idea actually what percent, but suppose that there were. So I want to just give you a heads up that I just made up these numbers, but sometimes I'll quote an article and then it's real. This one I made up. Okay, but let's look at it. 20% of all students taking stats at Lake Tahoe Community College are African Americans. Let's stop right there. So what I'm going to do is I'm going to take that phrase and turn that into symbols. And the symbol I'm going to use is P. P stands for probability. Parentheses. A is going to stand for African American. And then equals, well, 20% as a decimal is 0.2. Any questions on how I took this first phrase, 20% of all students taking stats at LTCC are African Americans, and turn that into P, parenthesis A, and parenthesis equals 0.2? You have to be able to do those kind of things. Okay, then we read the next. And that is 40% of all stat students at LTCC are non-STEM majors. So I'm going to go P, parenthesis, N for non-STEM. I use a letter, you never want to use the same letter twice, so just make sure you're using different letters. N parenthesis equals 40% is 0.4. Any questions on how I took that second phrase and turned it into this P of N equals 0.4? Okay, then the next is if 20% of Lake Tahoe Community College students non-STEM majors are African American. So now we're restricting to only non-STEM majors. That means we're given their non-STEM, and the probability that amongst those non-STEM that the person is African American will be 22% or 0.22. The way you write that is P, parenthesis, A, remember this little symbol is given the information of non-stem, equals 0.22. Any questions at all on reading that little piece? A lot of people have trouble with taking that little piece and knowing how to turn it into symbols. That's the hardest. Okay, then it says, and you pick a randomly selected African-American taking stats, find the probability the student is non-STEM. So now we pick an African-American. That means we're given the person is African-American. We want the probability of non-STEM. So that's P of N, non-STEM, then that given symbol, A, African-American. And I write equals question mark because that is the word find. Find means that's what we want to do. We don't know it yet, so I write it as a question. So let me stop for a couple seconds. And are there any questions on how I arrived at all these symbols? Okay, so now what we need to do is now we need to use the formulas that we had earlier. And remember, we had the probability of A given A and B equals the probability of A times the probability of B given A. And by the way, probability of A and B is the same as probability of B and A. Probability that someone's African-American and non-STEM is the same as probability that someone's non-STEM and African-American. It doesn't make any difference. And you can reverse. Okay, so we can take this equation and we could divide both sides by the probability of B. And what you get is the probability of A given B is the probability of A and B divided by the probability of B. So a little bit of basic algebra, but that's how we get that. Okay. So we can say the probability of A and N, remember the letters don't matter. You can change the letters as long as you know what you're talking about, will be the probability of N times the probability of A given N. Probability of N was 0.4. So there's the 0.4. Probability of A given N, that was 0.22. So there's my 0.22. We want the probability of N given A, which is the probability of A and N divided by the probability of A from this formula. Remember, you can switch A and B. To switch A and B, you got to do it in both left and right. And that's what I did here. Okay, and B was N in that case. So now the probability of A and N was the 0.4 times 0.22. Probability of A was 0.2. And when I divide that, I get 0.44. And there's my answer. So again, big heads up, it is much harder to do it yourself than to watch me do it. Because you have to come up with each of those steps by yourself. But are there any questions on that example? All right. All right, suppose you roll 2 6-sided dice. Okay, I got those over here. There's my dice. And I'm going to roll them. And I just rolled 2 6-sided dice. Now I'm not showing you what I rolled. What is the probability that I'm looking at this? What's the probability that the sum is a 5? Let's see if we can figure that out. Well, the first thing I'm going to do is make a fraction. How many sums of 5 are there? Let me give you one example. That is a 1 and a 4. that sums to 5, right? How many ways are there of adding to 5 with 2 dice? Any thoughts? And if it helps, I'll give you one more. There are others. That one sums to 5 too, a 2 and a 3. How many sums of 5s are there? Let's see, I'll jump it in. Let's see, there's a 1 and a 4, a 2 and a 3, a 3 and a 2, and a 4 and a 1. Yep, good. A few of you got it. Oh, there are 4 of them. How many different die rolls are there with 2 dice? Because that's the denominator. By the way, this should be easy. How many die rolls are there just for the first die? There's 6, because there's 6 sides. Okay. Now you can think about it as I could get a 1 for the first die, and with that 1, I can get a 1, 1, a 1, 2, a 1, 3, a 1, 4, a 1, 5, and a 1, 6. So there are 6 for this with a 1 and a something else. There's a 6 with a 2 and a something else. So we have 6 of 6s, or 6 times 6. So the denominator will be 36. Any questions on that example? Okay, so that's dice. I think I'm not going to do that one. Let's do this guy. Okay, so a survey was done, okay, or pretend a survey was done, okay, asking Lake Tahoe Community College transfer students where they plan on transferring to and what living situation they will be in when they transfer. Okay, and by the way, again, just like the survey was done, I'm making this up, but you can imagine a survey being done. Okay, and the main places that students transfer to are Cal State universities, UC campuses, University of Nevada, Reno, and other places. Okay, like private universities or whatever. Okay, and the main places that they're going to stay in will be an apartment with their parents or some other kind of place. Maybe they're going to be homeless. Who knows? Okay. So this right here is a table, and we call this a contingency table. So I want to just note, for example, this number 33. What this means is of all the students that were surveyed, 33 of them plan on transferring to a UC campus and will be living in an apartment. That's what that 33 means because of the placement of where it is. Any questions on how to read that? This 15, for example, means that of all the students surveyed, 15 will be transferring to some other college or university and will live with their parents. Any questions on that idea? All right, so we want to find the probability that a randomly selected student will go to a UC campus or live in an apartment. Okay, and just a note, if you add all of these numbers up, you get 246. I didn't want to waste your time, but you can imagine doing that. 43 plus 33 plus 19 plus 22 plus 34, etc. And you'll get 246. So how do we find out the probability that a randomly selected student will go to a UC campus or live in an apartment. So here's a very important formula, and that is right here. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And the reason why that works is we're taking the chance of the first thing happening plus the chance of the second, but then we've double counted. We've double counted both of them happening. And that's why we got to subtract the A and B. That's where it's coming from. So in our symbols, if we want to find out the probability they'll go to UC campus or live in an apartment, we're going to say P of UC or A, UC campus or apartment. And that, from the formula, is the probability that they live in a UC campus plus the probability that they're going to live in an apartment minus the probability that they go to a UC campus and live in an apartment. Any questions on that? And the good news is these are not too hard to do. The probability of a UC campus. So we go to the UC campus. We say, how many of them are there? Well, there's 33 plus 8 plus 19. 33 plus 8 is 41. 41 plus 19 is 60. So there's 60 UC campus students. And there were 246 total students. So that probability of UC campus is 60 divided by 246. Similarly, P of A, we got to count the apartments. 43 plus 33 is 76, plus 19 is 95, plus 22 is 117. By the way, you are never required, like I just did, to do it in your head. Use a calculator. I have a weird calculator brain. That's what they always used to call me when I was a kid. So use a calculator. Do not do it in your head. Don't even think about it. Okay? But instead, 117 divided by 246 will be the probability of living in an apartment. Okay? And as I mentioned, this 33 was counted twice. Once for the apartment people, once for the UC people. And that's why we're subtracting it. That's where this formula is coming from. So it's minus the probability of UC and A. That was a 33 over 246. And when you work that out, you get 144 divided by 246. 60 plus 117 minus 33 is 144. Any questions on that example? Any questions? All right, let's do some more. Okay, here's a definition, very important. We call two events, A and B, are mutually exclusive if the probability of A and B equals 0. So kind of in words, two events are mutually exclusive if they can't both happen. So for example, let's say we're going to survey a bunch of people where they were born. Let's say A is the event they were born in California, and B is the event they were born in Oregon. And those are mutually exclusive. Can a person be born in California and Oregon? No, that's not possible. You can't be born in two different states. Okay? You could have lived in different states, but not born in two different states. Okay. There was a question about, do you have to simplify the answer? So 144 over 246. I don't make you reduce it, or sometimes a computer will say round it to 4 decimal places. And that means just put it in the calculator and give 4 decimal places. Does that make sense? So that is something the computer will tell you to do. So not necessarily simplify, but sometimes write as decimals. And that's common to have to do decimals. Any questions on this definition of mutually exclusive? Okay, on the other hand, let's suppose that we're going to ask two different college students. And let's say event A is the event that the college student is Hispanic. And event B is the event that the college student is receiving financial aid. Are they mutually exclusive? Yeah, the answer is no, because the probability that some randomly picked college student is Hispanic and receiving financial aid is definitely not 0. You can be both. Does that make sense? So mutually exclusive is not hard, but you just gotta, write it down and remember it. That's all. So are transferring to a CSU and living with parents mutually exclusive? So all you have to do is calculate the probability of CSU and parents. And notice from this table, that will be 34 out of 246. And I hope you don't need a calculator to know that 34 over 246 is not 0. You have to have 0 on the top to get 0. So they're not mutually exclusive. I'll often use ME. I'm not talking about me. Mutually exclusive ME. Any questions at all on mutually exclusive? It's pretty easy. So if I ask you to show it numerically, that means you have to write down this part right here. And if you don't want to write the not equal to sign, for example, on the exams, it's fine to write NOT equal sign. I'll let you do that. Does that make sense? So if you type it in the keyboard, the symbol in the way it sounds, I'll let you do that. Okay. Here comes the next definition, and that's much harder. Just give you a warning. And that is two events are independent if any of the three are true. Probability of A and B equals the probability of A times the probability of B. Probability of A given B equals the probability of A. Probability of B given A equals the probability of B. If one of those is true, they're all true. If one of them's not true, then none of them are true. So if you have to show two things are independent, pick the one that is easiest for you to find and calculate. Any questions on the formulas and before I use them? Okay, let me tell you what independent means in terms of idea. Two events are independent, especially if you kind of look at it this way. A given B equals the probability of A. If you're told that B happened, then that doesn't change the probability of A happening. Okay, so an example I have is, let's suppose A is the event that the high school team in Sydney, Australia's high school soccer team wins their next game. And let's say B is the event that it's more than 50 degrees in South Lake Tahoe. These are going to be independent because the probability of A given B is equal to the probability of A. If I tell you that it's more than 50 degrees in South Lake Tahoe, do you know anything about the soccer game in Sydney, Australia? Nothing. So independent usually, not always, but usually means they have nothing to do with each other in terms of probabilities. Does that make sense? Knowing one tells you nothing about the other. Okay, and that's kind of the way you can read independent. Okay, some things you think they're independent, but it turns out they're not, or vice versa. My guess is the Sydney, Australia one is probably independent. Okay, and there's a lot of studies about things being independent or not. In medicine, for example, if taking a vaccine is independent of getting the disease, then the vaccine is useless. Does that make sense? Why would you take the vaccine if it didn't change your chance of getting the disease? On the other hand, if taking the vaccine lowers your chance of getting the disease, then those are dependent. We call it dependent if it's not independent. And you'd want to take the vaccine. Does that make sense? Okay, so that's an example in kind of the real world. All right, so are living in an apartment and transferring to UNR independent? So you get to choose any of these three. The first one, I'm gonna have to calculate three different probabilities, right? There's three P's there. So no reason to choose the first one. Let's choose the second one. Sometimes the first is easy, but not in this case. Sometimes they've given you some stuff, but here they didn't. So let's find the probability of A given B and see if that's the probability of A. And in the symbols I'm going to use is the probability of apartment given UNR. Is that the probability of apartment? Okay. So let's look at this. Probability of apartment given UNR. So if we're given that they're in UNR, that means they're one of these three, this 19, 7, and 15. Of those, 19 are in an apartment. So that's that formula that A, probability of A given B is the probability of A and B divided by the probability of B. Okay, so that's going to be 19 divided by all the UNR people. 19 plus 7 is 26, plus 15 is 31. So that's going to be 19 over 31. Okay, probability of being in an apartment. Well, that's the total number in an apartment. Okay, which we actually counted already. If you remember, that was probability of being in an apartment was this one, 117 over 246. I'll copy and paste it because we already found that one, right? Okay, now this is something that, you don't want to do this in your head. How do you tell if these are equal or not? What's the easiest way to decide if two fractions are equal? Remember, you're allowed calculators, always. What's the easiest way to decide if fractions are equal? Any ideas? Let's see. All right, let me tell you. Turn them into decimals. It's really easy to see if decimals are equal. So we have 19 over 31. And that's 0.6129 about. And then we have 117 over 246. And that's 0.4756 about. And now it should be really easy. Are those equal? Are they equal? Yeah, definitely not. 0.6129 is not 0.4756. So it's much harder to like look at fractions and decide they're equal without calculating, but decimals are really easy to tell. So that's what I recommend is turn them into decimals. So we can say since they are not equal to each other, then living in an apartment and transferring to UNR are dependent. They're not independent. We say they're dependent. Any questions? Any questions on this example? If we got the same number, then we'd say they're independent, but we didn't. Okay. Again, the big warning is easy to watch me do it. Much harder to do it yourself. What I'm going to tell you now is the secret word. Okay, and the secret word is probability. Because that's what this chapter is all about, is probability. That P of, that stands for probability. P is the first letter of probability. So probability is a secret word, so make sure you put that down. By the way, you may think we're not ending early. Remember I told you, remember what the last thing we're going to do is today? The last item on our list? So hopefully you all wrote down probability for the secret word. Project 1. Okay, so I want to spend the rest of the time talking about what the expectations and plans, timelines and all that are for Project 1. Okay, Project 1 is a big part of the grade, so, pay attention. So what I'm going to do is I'm going to go to the Canvas shell and look at a few things. First is Project 1 is 10% of your grade. So again, if you don't do Project 1, pretty much you cannot get an A in the class. So it is important. So make sure you do it. And then I'm going to scroll down some more and we can look. Project 1, students are going to collect quantitative data. Who remembers what the word quantitative means? What does quantitative mean? That's important. It happened last week. Yeah, numerical. And in particular, you're going to have to do a survey question. And the answer to the survey question for everyone who answers has to be a number. Okay, so do not ask something like, do you like baseball? Because what would the answer be to that? Yes or no, and that's not a number. Okay, so make sure that you have a quantitative data, quantitative variable. One thing I recommend doing is, since you're working with partners, ask your partner the survey question. If a number doesn't come out of that partner's mouth, then that doesn't work. Does that make sense? So you could test it with each other. Okay, it's a good idea. All right, you'll notice here, I have this Project 1 is linked. And these are the Project 1 requirements. And I'm going to talk about them, kind of go through each of these bullet points and make sure you understand. And please ask questions, okay? And something I noted last week, by the way, is that you must work with partners. Okay, there's a 25% penalty for not working with partners. Okay, and this is very sad. Most quarters, I have one student, usually one, sometimes two, who don't work with partners. And they pretty much never pass because losing 25% makes it almost impossible to pass. You'd have to like get a super high, super project, and then you just get a C. But it's almost always Fs. So have partners. And if you have 3 and 1 drops off, you still have 2. You can search for a third. But, 3 is best, 2 is okay. So that's a big, big must. And the hope is you already have partners. If not, get them like ASAP. Do not wait. Do not wait 3 weeks from now and say, hey, I don't have a partner. What can I do now? Cry. That's what you can do. You need partners. Got it? Okay, so now let's go through each of the bullet points. So think of a quantitative investigation that someone might contract out to have done, in theory. So you're going to have to think about a survey question that somebody would be interested in and maybe pay money for. Okay? You don't have to get someone to pay money, but at least in theory, you should talk about who might pay money to have you do this research. Does that make sense? Okay, so in your project, you actually have to state who is your, I call them the client. Who is your client? Okay? And in theory, your client could be President Biden. Even though maybe you can, but I could never get President Biden to talk to me. But you could pretend President Biden would talk to you, and he'd be interested in learning about what you're talking about. Does that make sense? And using it to make decisions. Okay, so it could be, a counselor at our college if it's counseling students on something. Does that make sense? And that could be your client. It could be the manager at McDonald's if it's about something about McDonald's. Does that make sense? Okay. The one thing that you are allowed to do, even though it may not be true, you're allowed to assume your client understands statistics because your client is going to be the audience of who you're writing this paper or report for. Okay. It may feel like it's me, but it should be written as in the audience as your client. Does that make sense? And you can assume the client understands stats. Okay, then you're going to go and perform this investigation. Okay, and report on it as though you were having to report to the person paying for your services. Okay, so this is a study where you are going to conduct a survey. You were going to ask people survey questions. Got it? Okay, 1 survey question, by the way, for the survey question. Okay, the purpose of the report is to make recommendations on the findings. So throughout the entire project and paper that you write, every time you look at something, you have to make a recommendation to your client on how the client should use that information and what decisions the client should make. Okay, not just at the end, by the way, throughout the entire paper. Okay, you should include a statement on who has hired you and why. And below are the items that you must report on. And here they are. 1 is a description of the sampling technique that was made and how the technique was applied. Okay, you have 2 choices, basically. 3 officially, but really 2. Simple random sampling, stratified sampling, or cluster sampling. What did I tell you about simple random sampling of, say, all Americans? You remember? It's not possible. So it can't be done. So simple random sampling is probably not going to be happening. Okay. On the other hand, stratified sampling can be done, and so can cluster sampling. Choose one of those 2, basically. I provided a link for this page that goes over what stratified sampling looks like and what cluster sampling looks like, in case you forgot. It's also in the book. It was in last week's video, webinar, but there's also links directly to them. So basically, you're going to choose one of those 2. Okay, any questions on that? Okay, you have to discuss your sampling technique, what you did. You also must discuss any bias that might have occurred due to your sampling technique. If you think there's no bias, think again. It's like not possible to do a survey of people without having any bias. So I do not take off points for having bias. I take off points for not writing about the bias. I give you points for writing about the bias. Does that make sense? So don't think that you should have no bias. That's just not going to happen. There should be reduction in bias with either stratified sampling or cluster sampling, but not becoming no bias. Okay. Bias involves a misrepresentation of the population. Okay. So that the sample data will not represent the population data. Okay. In particular, you should talk about whether, based on the bias, do you think the sample mean is less than the population mean or more than the population mean? Because that's what bias does. It skews the mean one way or another. Okay. Here's a note. The sample size must be greater than 30. So what's the smallest number greater than 30? This is not a trick question. You should all know. For a sample size? What's the smallest number of people that you can survey? Greater than 30? Put in the chat box. Should be obvious. I promise you it's easy. It's the smallest number of people greater than 30. Good. 31. 31 is the smallest number greater than 30. So you're allowed to have a sample of 31. You can have a sample of 35. That's fine. Or 40. I strongly recommend not having a sample of hundreds. That's just too much work. There's only one reason why it makes sense to have a sample for this project, to have a sample size that's like in the hundreds. My guess is none of you are going to guess the reason. And I've had it happen a couple times in my many years of teaching, but it's happened. Should I tell you? Because you work for a company and actually you're going to be using your survey for your work, not for your class, but also for your work. And for your work, they want you to have some super large sample size. But other than that, don't even think about it. Okay, it's very rare that happens. But you must be greater than 30. 30 is not greater than 30, by the way. Okay, so if there's 3 of you, that means 11 each is good. Does that make sense? Because that'd be 33 people. Is that clear? Okay. So you have to have sample size greater than 30. The number 30 is going to be very important, but that will not happen until chapter 7. So right now, just trust me. Greater than 30 is important to have any importantly good survey. But chapter 7 is when we're going to learn about why. And that's not part of this project. It will be part of project 2, though. How do you find partners? Remember, that was in the project 1 discussion board. You go to that discussions panel right here. Click on it. And you'll see project 1 discussion forum. Click on that. And then find partners. You'll see a lot of people posted already. Okay. I can't click on it because it's going to show names, and I'm not allowed to show names for public postings. But you should click on it, and then you can post. Okay, very important. I would do it like tonight. Don't wait longer than that. It's very easy, but you just got to do it. There's some people that have already posted they're looking for partners, so that's important. And you can reply to them and say, let me be a partner. There's already 3 in there. It's too late. But if no one has answered or only one person has answered, answer them. If not, If you don't see anyone that hasn't had two other people answer, then post yourself. Okay. I do want to let you know, this is important. I never talk about names, but I'm reading your post, is that we have two sections in this class. You are allowed to be partners with people in a different section, but they won't see your post. So shoot me an email, for example, won't work if you're in different sections unless you give the email out. And I'm not allowed to give emails to each other. So I just want to mention that. I don't remember who's in which section. Yeah, sorry, there's two sections, and you might be in the same. You can talk to each other about that. So again, there's all kinds of like laws about that kind of stuff, and I can't break them. Okay, you're allowed to work together, but I'm not allowed to make you work together in different sections. Okay, all right, so here's a word that you should avoid, and that is random. If you think your survey is done in a random fashion, think again. It's like almost always impossible. So think again. Don't use that word. The only time you're going to use the word random is say, this was not random. That you can say. Because good luck doing random. It's not going to happen. So, and I'll take off points if you say it was random and it wasn't. All right. So then just a note, if you do stratified sampling, and let's say you decided to stratify by age bracket. Okay, then you're going to have to ask people how old they are. And you're going to also ask people the survey question. The how old they are is only for the stratified part. Your data is one column of data, not multiple columns. You don't get a column of data for each strata. You put them all together. That's just a note because it's a common mistake. I want to mention all the common mistakes people make, and that's a common mistake. There should be one column of data. And I want to let you know, I want to remind you, I said it last week, but I'm going to say it again. In your study, in your survey, you have to use the spreadsheet. Statistics by Larry Green is strongly recommended because that's got a spreadsheet and it's made for this project and project 2, by the way. And once you do that, remember you have to go to File, and then you have to go to Make a Copy. Give it a name, and then hit Make a Copy. Then what you do is you highlight these numbers, you hit the backspace, and then you get to start with your numbers. Any questions on that? Then you enter your data, and that's the 31, or it could be 33, or however many you have. Better have at least 31 numbers. And you might have, I don't know, 45 for the first person's answer, 27 for the second, 11 for the third, etc., etc., etc. And you're just going to have all those numbers, and then it will give you everything you need. Okay. And then I want to remind you, if you go to stats, you can get the box plot and the stem and leaf diagram. You are required to have a stem and leaf diagram for this project. So make sure, because it's a mistake a lot of people make, your survey question has to have answers that are at least 2 digits. So do not ask how many siblings are in your family, because you'll probably get nobody saying 11. Okay, you're going to get only 1-digit answers. Does that make sense? Don't do a scale of 1 to 10, do a scale of 1 to 100 if you can do a scale type of thing, because then you get 2-digit answers. Is that clear? So make sure that the answer to the survey question are mostly 2 digits. You're allowed to have 3, and then you just round to the nearest, to the 2. Any questions on that? Notice there's a minimum, a mean. Variance is not important. Don't even talk about it. But standard deviation is the biggie. Okay, I'll talk about that. And let's go back to, not that one, that one. There it is. So you must have a histogram, a stem and leaf. You must have a box and whiskers. Those must be in your project. Okay, and by the way, I'll say that in a minute. If it's reasonable, you can include a pie chart or a line plot, but the three has histogram, stem, leaf, box, and whiskers. Those are absolutely required. Okay. You must use a spreadsheet program. Okay. And what you're going to do is there's a histogram, for example, is you're going to copy this guy. I'm going to hit the right arrow, and then you can copy it. Let's see. You can go Control C, and then you can paste it into your project. Okay. And you also must copy and paste columns C and D. Copy and paste it into your paper. Got it? That has to be done. That's proving that you use the spreadsheet. Okay, and you should also copy and paste the stem and leaf and the box and whiskers plot. Those have to be in the project directly in. Any questions on that? It's not hard to do. I can help, a tutor can help if you can't figure it out, the tech, but it's really not that bad. Okay. And then just a note, for each of these charts, you should talk about what decisions the client is going to make based on that chart. And then what decisions based on the next chart throughout the whole chart. Okay, make sure you talk about the highlights of the chart. For example, a histogram really is all about the shape of the distribution. Is it normal? Is it uniform? Is it bimodal? What can you do based on that? And also, what does it show? Stem and leaf. Some main things in stem and leaf. It talks about that middle 50% of the data and what you can do with that. And it talks about quartiles. I'm sorry, not stem and leaf. Box and whiskers is middle 50%. I apologize for that. So the box and whiskers is that middle 50%. The stem and leaf, that one also shows you the shape, but it also will give you the mode. Okay, it shows you the actual data. You can see how many people said 40 or whatever that might be, and how your client is going to use that. What decisions will your client make based on it? Okay, any questions so far? You should also compare and contrast the charts and what they mean and what they tell you. Okay, you should give a list of the summary statistics and interpret each. Okay, and those are the ones that we've covered in our class. That's the important thing. So again, the minimum, the mean, the standard deviation, the median, the maximum, the third quartile, the sample size, the first quartile. We haven't done confidence intervals, so don't even talk about confidence intervals or p-value or t. That comes later in the class. Okay. Talk about the z-score. Okay, and see where it says change this. If you don't change that, then you don't understand the z-score. Okay, it's an x value and it's z-score and how you're going to use it. Use the z-score to decide on whether there are outliers, for example. Use the z-score to talk about the most important value of x to your client. Those are the kind of things. Okay. These don't matter. Population standard deviation, you can't know that from your data. IQR, that we know. Okay. There can be a mode. Not in this case, but there can. None of this matters. Yeah, none of this stuff matters, this bottom stuff. Some of the stuff I put in for other teachers and other colleges that wanted it. Okay. For each of those important things, for each of those important statistics, make sure you talk about the decision your client is going to make based on it. Got it? Also, go over the Chebyshev's theorem or the empirical rule. If you can use the empirical rule, use it, and then you don't need Chebyshev's theorem. If you can't use the empirical rule, then use Chebyshev's theorem. Use the histogram to make that decision based on the shape of the distribution. And then what decisions will the client make based on it? Any questions on that idea? All right. You should also talk about, usually at the end, talk about what further studies could be done to delve deeper in the topic. Maybe what other survey questions might you ask to get more information. Also, what you might do if you had like a huge amount of money and time to reduce the bias that you have identified. Okay, and that's all in theory. I don't expect you to spend any money, by the way. A couple things that are important, and I mentioned it last week, but I want to mention again. You are not allowed to survey children. Who remembers why? Not because I hate children, by the way. Why are you not allowed to survey children? If you remember? Don't see y'all jumping in. It is against the law. It's not about me being mean or something. It is against the law without, a ton of forms, having a lawyer help you out on what's legal and what's not legal. Don't even think about surveying children. Okay, don't go to a high school and asking a bunch of high school kids that are freshmen and sophomores and stuff like that. The only children you actually are allowed to survey for this class are if there is, say, a 17-year-old in our class, you're allowed to survey your fellow students, even if they're under 18, but only your own fellow students. Does that make sense? If it's a college student at your college and they happen to be under 18, you're allowed to ask them. And that, it turns out, their parents have signed away any lawsuit that they could do based on a survey of a student for a class. And that's a legal thing. But if they're not a college student at your college, you cannot survey them. Got it? You want to hear something horrible? This was a very long time ago, but it happened. I had a student I knew surveyed a child because my daughter, when she was young, came home and told me that one of my students surveyed her. Isn't that awful? So I actually had proof that they surveyed a child. It was my own child. I didn't sue that student, but I could have. So do not survey children. Got it? The other thing is if you're going to do a study about, let's say you work for a restaurant and you want to survey people about how much they spend, at the dinner. And let's say you're one of the, you're in the wait staff for that. You could do that, but something I want you to do is make sure you get the okay from your manager. I don't want anyone getting fired because they did a survey and their manager got pissed off. Got it? So just make sure that you get permission. If you go to any business, get permission from the manager so you don't get in trouble. Got it? And you are allowed to survey people at a business, but like if you go to the supermarket near your house, make sure you get permission from the manager that you're allowed to do that. And they'll usually say yes. Okay. I want to say one more thing that helps is that you're much less likely to have voluntary response bias if you start out by saying, I'm in a statistics class and it's really hard and we have to do a survey for the class. Can you answer my survey? They'll all say yes. If you just say, I have a survey to ask you, a lot of them are going to say no. So if you want to reduce voluntary response bias, tell them you're in the stats class and it's for your class so that you can get a good grade. And then almost everyone will answer your question. Does that make sense? My guess is you would answer someone's question if they asked you that, right? Because you'd feel sad for them because they're in the stats class or something. So then that's just it makes it much easier to get a higher sample size to get that over 30. Whereas if you don't say that, then it's much harder to get that. Okay, especially if they think you're making money off of it or something like that. Also tell them it's just one quick survey question and it won't take more than 10 seconds of their time. They like that. Okay. I do have a link that past feedback that I've given other people. And you're welcome to click on that link and take a look at some of the things that other people made mistakes in. Let me give you a bit of a timeline. So I've already talked about this one, and that is, when should you find partners? Who remembers? Yeah, ASAP or already found them. Okay, do not wait. That should have already happened. Okay, get partners, okay? Be really nervous if you don't have a partner already. Make sure you get partners, okay? All right, so note that the project is due May 12th. That does not mean you should start on May 11th to do this project. So May 12th, the project must be submitted. It's a disaster if you turn in late, by the way. So don't do that. Okay. I don't recommend turning it in May 12th. I recommend turning it in May 11th or May 10th. That way, if some internet connection happens, you don't have a disaster. Do you see that? Not too often are you like out of internet for more than a day, probably, where you can't go to someone's house and get it if you can't get it or something. Or if you live in Tahoe, you come to our college or whatever. So a day or two before might be the best idea to submit it. Then also, if you remember, I will look at your draft of the project if you submit it by 8 a.m. before it's due, but there are 60 students in the class. It might take me a long time to read it if you submit it the last minute. And I read it in a first come, first submitted, first read basis. So if you do it like by like Tuesday of that week, then it's much more likely that I'll be able to read it earlier. Does that make sense? But if a whole lot of people send it on Thursday morning, it might be a day or two before I can read it, because it might be 100 pages of reading or 200 pages of reading to do and a whole lot of typing comments. What I will do is I will read it and then type in usually like 10 or 11 comments on how to make improvements so that you can get a better grade. If you don't send me the draft, then you don't hear my suggestions. And instead of me typing comments on how to improve it, then you've just submitted it on that Saturday or Sunday. And those comments are going to be, and I'm taking off points because of this, instead of here's things you can do to make it better. You make it better and you don't lose the points. Do you see how that works? So that's just a note. So again, that May 12th is a Sunday, by the way. And if you take that Sunday, subtract, 5 days or so, then that's May 7th. And I recommend, kind of thinking about trying to get that project done for your draft by May 7th. So again, it's coming up. That's only a few weeks, 3 weeks or so from now. I recommend by maybe next week, within the next 7 days or so, having your partners, meeting with your partners, coming up with an idea for a project. What should your survey question be? Who should your client be? How are you going to conduct the survey? What sampling technique? And then post that information, your idea, on the Project One discussion board, maybe within a week or so. I'll look at it, and I'm pretty quick on getting back. Within a day, I'll get back to you. And I'll let you know, yeah, this is going to work great. Or, it's pretty good, but here's a few things you might want to adjust to make it work. Or, sorry, but your survey question is a yes/no question. This isn't going to work. You need to change. Does that make sense? So I'll let you know whether it can work or not. Then once I've said, yeah, this can work, which again, won't take much time. I'm quick. Then, but not 5 minutes, by the way. And something you'll learn, I'm not a night owl. I'm a morning person. I don't know if you noticed, but I had the, that in the morning I had your stuff graded. I don't answer questions after like 9 at night because I'm asleep. So don't even imagine questions after 9 at night until then I'll wake up in the morning and get to you at like 6 in the morning or 4 in the morning sometimes even. So just a note, just in terms of how things work. So that's how that'll work. Then once it's a good project, you're ready to do it, then conduct your survey. Okay, shouldn't take that long to conduct your survey. Might take a few days, might take a week, but I recommend having your survey conducted maybe by like the 25th or so. So April 25th-ish, just giving you kind of a good idea of timeline. Because then once the survey is conducted, then you put it into your into the spreadsheet, which I recommend sharing on Google Sheets, by the way, so that you can work at it together. And then once you have it in the spreadsheet, then spend a week or so on writing up your draft. And maybe even like in the next couple of days, decide who's going to write what part. Okay, and before you send the draft, make sure you share with each other so that you can like make it pretty good. Does that make sense? So you can all read it. Instead of, I only read my part. Try to read each other's part. Any questions on the timeline? Okay, we're about at the end of my goal. 7:40 is my goal. When I have to talk about the project, it always takes a little bit longer. So I am going to stop the recording. And we didn't lose internet today. It's better work this time. And then I'll answer questions.